Welcome everybody to an extra video where I will discuss a couple of examples for Gaussian elimination and finding the solutions to a set of linear equations. Now, there will be three examples highlighting each of the that are possible for the solution set of a system like this, is that there's a unique solution, infinitely many solutions, and no solutions. But we will start with this one. And I'm not going to tell you what the solution is yet, or what type of solution it is. We're just simply going to start with matrix 1, minus 2, 1, 0, 0, 2, minus 8, 8, minus 4, 5, 9, minus 9. And it is important to realize what we're working towards. We're working towards a solution which might look like x is equal to something, y is equal to something, and z is equal to something. And this set of equations is our equation here. So that means we're trying to work towards something like this, where these dots represent the answers for x, y, and z. It may end up that we have infinitely many solutions or no solutions, but this is what we're working to get. And the idea is that, well, the first step is to get a 1 in the top left position. There's already it, and we see that we already have the first 0. What I'm going to do for the next step is add the first row 4 times to the third row, which gives me a 0 here. Now, for the sake of space, I'm just going to continue over here. So the first row doesn't change. 1, minus 2, 1, 0. The second row doesn't change. Minus 8, 8. And the third, well, minus 4 plus 4 is equal to 0. 5 plus 4 times minus 2 is 5. 9 plus 4 doesn't change because we have a 0 here. So minus 9 plus 4 times 0 is still minus 9. Now I'd like a 1 here. Sometimes it's not quite possible. You get fractions. They use different tricks, as we've seen in some of the exercises. But this one we can simply transform into 1 minus 4, 4, 0 minus 3, 13 minus 9. Now, the next step is to continue to work towards that form. 0 here, and I can achieve that by adding the second row 3 times to the third, which gives us, well, the first 2 rows don't change, so I can copy those. 1 minus 4, 4, 0 minus plus 3 is equal to 0. 13 plus 3 times minus 4 is 13, minus 12 is equal to 1, and minus 9 plus 12 is equal to 3. Now, this is the point where the book stops. We have this last row. These two aren't in this form, but this is where the book stops. And that's all fine, because what do we have here? We have this last row represents the part of solution where z is equal to 3. Well, the second row is y minus 4z is equal to 4, but as we know the value of z, 4 times z is 12. Y minus 12 is equal to 4, which means that y is equal to 16. Then we have the first row, x minus 2z plus y is equal to 0. Well, as we minus 2y plus z is equal to 0. Y is 16, so x minus 32 plus 3 is equal to 0, which means that x is equal to 29. And our solution is given here. X is equal to 29, y is equal to 16, and z is equal to 3. And this is our solution. So this is what the book does. We do here, the Gaussian elimination. The answer. There is another way where we continue from here and also do where we create zeros in the bottom left hand corner. We now try to get zeros there, and of course we have the ones in these positions, that position, this position as well, to make calculations easier. But let's just continue on. But this is fine. You don't have to continue beyond this. Well, let's see how we get there. I will add the third row 4 times to the second, and I will add it minus 1 times first. So what do we get? Well, the bottom row stays the same. 0, 0, 1, 3. 0, 1, 0. 4 plus 3 times 4. 4 plus 12 is 16. And we get 1, minus 2, 0. And we subtract the third row from the first row. So, well, adding minus 1 times the third row to the first. Minus 3, and we get this step. Well, there's only one more step to go, and that is to create a 0 here, and I can do that by adding the second twice to the first. We get 0, 0, 1, 3, 0, 1, 0, 16, 1. This becomes a 2, 9. And I have exactly the same solution here, but now I can immediately write x, y, and z instead of doing the substitution. So it's either one or the other, it doesn't really matter. You could also solve this completely. There's not something. This was example number 1. And we see we have a unique solution.